Okay, pre-AP kiddos, I'm making you this video to help you out with the second page of 2F. I want to talk to you guys a little bit about um, exponents and square roots and sort of how to convert them in case your calculators don't have that. Okay, um, so I want to start off with if we have the square root of x. I know it's over on the sheet, but I want to just look at it anyway. So if I have something like the square root of x, okay. Now, if we don't have a number in there, really there's a number 2 in there, right, to sort of show that we're unsquaring it, okay. Now, if we're going to take the square root of x and we're going to change it to where we could type it in a calculator as an exponent, we can do that, okay, by changing it as x to the 1/2 power. So we could plug it into the calculator as x to the 1/2 power, and you probably need to look at that little caret button there in your calculator to do that. Okay. The reason why that is, so inside the radical we have x. Okay, there's no exponent, so if there's no exponent, it's really x to the first power. Okay, so we have x to the first power right there, but it's to the second root, the square root. Okay, so it really becomes x to the 1/2 power. Okay, x to the 1/2 power. If I were to look at another example, okay, and this one really sort of helps us on this first one, so that just becomes x to the 1/2 power. Again, good to put parentheses around the exponent. Okay, let's say we have something like this. Let's say we have the fourth root of, I don't know, x to the 6th power or something like that. Okay. So again, we can convert it into the exponents into a fraction of x to the 6/4 power, okay, which would really be, x to the 3/2 power, or you could put it as x to the 1.5 power. Either way would work, okay. So we have 6 as the exponent, so that goes in the numerator of our fraction. 4 is the root, so that goes in the denominator of the fraction, okay. And this math is more good for algebra 2 type stuff, but it'll sort of help us as we go along here with some of our scale factor rules. If we were to look at it in reverse, let's say we have x to the, I don't know, the 4/5 power or something like that. All right, if we were to work that in reverse, now we know we have x to the 4th power taken to the 5th root, okay? And the reason I'm teaching this is not a lot of calculators can do, where we can do a different root. If we were to pull up the Google calculator here on the screen, all right, see all we have is a little square root thing right there. And so if you were to use a Google calculator, you'd have to be able to raise it to a different exponent. So if we had, if we wanted to find the cube root of 12 or something like that, we'd have to go 12 roots, and inside the root, we'd have to go to the 1/3 power like that to find what the cube root of 12 is. Okay. If we were to go to our Desmos calculator, we go to Desmos calculator and pull that up. Where is that? Math tools, scientific calculator. All right, if we go to a Desmos calculator, which we may have used before, we could hit the root button here and we could put our number up top. So a cube root of 12, and again, it would give us the same answer that we had, 2.289 on the Google calculator right there. But this is just a way to rewrite roots as exponents and be able to plug them into our calculator like that. Okay, so you can try these 8 example problems right here. But I want to go down and sort of go over fill in some of these blanks here on the bottom. Okay. So we kind of talked about the first 2 pages here. So for a review, let's say we have a shape that is dilated by a scale factor of x. Okay, whatever the scale factor is. Okay, The perimeter and the circumference will also multiply by x. Okay, and again, this goes back to our unit 1 stuff, to where if we have a square that's 1 by 1, we know the perimeter is equal to 4, right? If we dilate that square by a scale factor of 2, so now it's 2 by 2, the perimeter is 8, so the perimeter also dilated by 2. Okay, now we know that the area scale factor is going to be the scale factor squared. Okay, so if it dilates by x, the area scale factor is x squared. Now, to go one step further, if we're talking about volume, now volume is 3 dimensions. Okay, so if we have let's say we have a cube, for instance, here, we have a cube that's 1 by 1, 1 by 1 by 1. All right, that volume is going to be equal to 1. All right, if we dilate that cube by a scale factor of 2, right, and it's 2 by 2 by 2, well, that volume is 8. Okay, so the scale factor was 2. Okay, the surface area scale factor would be 2 squared, which is 4, but the volume scale factor multiplies from 1 to 8. So it multiplies by 8, which is our scale factor to the 3rd power. Okay, so whatever whatever happens, whatever the scale factor is, the volume will multiply by the scale factor to the 3rd power. Okay, and I'm going to look at a couple example problems below before I have you do the 3 on the back. Okay, so now these next 2 rules are basically the same rule as this, but it's sort of mirrored in a way to where we can adjust it depending on what we're given. Okay, so if the area scale factor is A, so let's say we have an area scale factor A where one shape is dilated to another and the area multiplies by A, we know that the dimensions are going to multiply by the square root of A. Okay, so the regular scale factor, okay, of the scale factor of dilation would be the root of A if the area multiplies by A. Okay, again, it's just going the rule in reverse. Okay, so now once we have the original scale factor A, or the root of A, okay, we know that the volume scale factor is whatever the regular scale factor is to the 3rd power. So it's the root of A to the 3rd power, or we can call it A to the 3/2 power. And we'll look at some examples here in a minute. Okay, so basically what we want to do is we want to go back and we want to work back to the scale factor of dilation and plug in our rules. Okay, so here they gave us a scale factor of dilation. Here they gave us the area scale factor. So if they give us the area scale factor, we have to square root it first. Okay, we'll square root the area scale factor first. And then since the area scale factor is the square root of A, the volume scale factor is the square root of A to the 3rd power. Okay, following the rules that we sort along here. Okay, now let's say the volume scale factor is B. Okay, so let's say we have 2 different shapes. Okay, another shape that gets dilated, and it dilates to where the volume multiplies by B. Okay, so if the volume multiplies by B, all right, we got to work backwards to find the scale factor. The scale factor would be the cube root of B. Okay, the cube root of B. Okay, or we can call it B to the 1/3. Okay, so with that, the area scale factor is going to be this thing, okay, whatever the original scale factor was, squared. Okay, so that would end up being B, the cube root of B squared, or we can call it B to the 2/3 power. Okay, this may be a little bit confusing, but I'm going to tell you guys this. Okay, so we'll use this first one if they give us the scale factor of dilation right there. We'll plug in these rules up top on this one. If they give us the area scale factor, we'll use that second rule. If they give us the volume scale factor, we'll use the rule on the third thing right there, okay? We do have 3 example problems. Now, the 3 example problems I have below are not on your notes, so you may want to copy them down on a separate sheet of paper, but I want to look at these 3 on the bottom here together. Pause the video if you need to, and copy down what you can. All right. All right, so coming down here. So a prism has a surface area of 200 and a volume of 600. If it is dilated by a scale factor of 0.8, what is the new surface area and the volume? Okay, so we're going to go to our first rule that we had up there. So we know that the scale factor is 8, or is 0.8. Okay, so the scale factor is 0.8. The area scale factor is 0.8 squared. Okay, the volume scale factor is 0.8 cubed. Okay, so the surface area is 200. We'll multiply the 200 by 0.8 squared to get our new surface area. Okay, the original volume is 600, so we'll multiply the volume by 600 times 0.8 to the cube power right there. Okay, because that sort of fits our scale factoring rules. Okay, so that's how we'll look at those. Next one, cylinder has a surface area of 400 and a volume of 250. The cylinder is dilated. We don't know the scale factor of dilation, but the new surface area is 300. Okay, so let's think here. So they don't give us a scale factor. Okay. Now, they give us enough information to get the area scale factor. Okay. So if the original surface area was 400 and the new surface area is 300, we know that the area scale factor is 3 over 4. Okay? The area scale factor is 3 over 4, dilates by 3 over 4. Okay? Which is equal to 0.75. Okay? So let's work that backwards to find the scale factor of dilation. Okay, so the scale factor of dilation is going to be the square root of 0.75. All right, and the square root of 0.75, let's pull up our calculator here. 0.866, we'll call it 0.87. Okay, now the volume scale factor is always the scale factor to the third power. Okay, so the scale factor was 0.87 or 0.866, whatever. Okay, let's keep it at 0.866. So the volume scale factor is going to be 0.866 cubed. Okay, so the scale factor of dilation is going to be the square root of 0.75, which is our 0.866. All right. The new volume, well, okay, the original volume was 250. And we know the volume is going to multiply by 0.866 to the third power. Okay, plugging in our rules and our formulas there. Okay, so this one sort of mirrors our second rule right there because we found the area scale factor first. Okay, so find the area scale factor first, work backwards, find the scale factor, cube it to find the volume scale factor. Okay, on this last one, a cone has a surface area of 120 and a volume of 50. All right, the cone is dilated and the new volume is 370. Find a surface area and a scale factor of dilation. So scale factor not given to us. area scale factor, not given to us. Volume scale factor, all right? So we know that the first volume was 50 and the second volume was 370. So our volume scale factor is going to be 370 over 50. So the volume scale factor is 7.4. That's what the volume multiplies by. So if they give us what the volume does, we're going to work backwards to find what the actual scale factor is, okay? So the volume scale factor we know is the original scale factor of dilation cubed, okay? So we need to take the 7.4 and uncube it, okay? So the scale factor is going to be the cube root of 7.4, okay? So we'll take 7.4 and we'll raise it to the parentheses 1/3 power, like that, okay? And we get 1.948, so we'll call it about 1.95. All right. Now the area scale factor is going to be that 1.95 squared. Okay. So we'll square that thing. And we get 3.797, so about 3.78. Okay. So it asks find a new surface area. So the original surface area is 120, so we'll do 120 times our 3.78 to get our new surface area. The scale factor of dilation, well, the thing was dilated by that, the 1.95, because the volume multiplied by 7.4, and we had to cube root it to get that, okay? So use these rules and use these sort of guidelines to do the 3 problems here on the back. And that will be it for the 2 F notes. Thank you and have a great day.